Students, today I am going to discuss an important class 12 mathematics science stream. The topic is increasing and decreasing function. So I adopt a question to make you understood in a better way. The question is, given a function fx equal to x square minus 4x plus 6. So find the interval at which the function is strictly increasing. Question number 1. So question number 2 is strictly decreasing. That means we need to show for this given function fx equal to x square minus 4x plus 6 at which interval the function is increasing, strictly increasing, and at which interval the function is strictly decreasing. So we know that a function fx is strictly increasing when f dash x is greater than 0 and strictly decreasing when f dash x is less than 0. For solving this problem, we follow the following steps. See the solution. Step number 1 is, in this step, we find the critical points for this given function fx equal to x square minus 4x plus 6. So how we find the critical points? By equating f dash x equal to 0. So in the step number 2, what we do? So in step number 2, by the critical points, we divide the real line into subintervals. That means we divide real line into subintervals with the help of critical points. So in the step 3, what we do in the step 3, we check in which subinterval the function is increasing and the function is decreasing. Then from that we can conclude that at which interval the function is strictly increasing and strictly decreasing. Okay? That means so in this subinterval, we check whether the function is strictly increasing, whether this function is strictly decreasing, whether the function is strictly increasing, whether the function is strictly decreasing. So we check. So after that we conclude that at which interval the function is increasing and the function is decreasing. Now following the steps, we first find the critical points for this given function fx equal to x square minus 4x plus 6. Then we divide the real line into subintervals with the help of the critical points, and then we check at the intervals on the real line where the function is strictly increasing or where the function is strictly decreasing. That means we need to check at which interval f dash x is greater than 0 and at which interval f dash x is less than 0. So let's solve. So first we find the critical points. For that we first differentiate the given function fx equal to x square minus 4x plus 6. That means f dash x equal to, we have twice x minus 4. Then we equate to 0 f dash x. That means f dash x equal to 0. Then we have twice x minus 4 equal to 0. From here we get, after solving, x equal to 2. Now what we need to do is, we divide the real line into subintervals with the help of this critical point x equal to 2. That means on the real line we have on the left hand side minus infinity and on the right hand side we have plus infinity. And we taking this point x equal to 2, we divide the real line, that is this line, into two subintervals. That means 2. So on the left hand side we have an interval 2 to minus infinity, and on the right hand side we have an interval 2 to plus infinity. That means we have two subintervals, that is open interval minus infinity to 2 and open interval 2 to infinity. And at this two interval we check whether this function is strictly increasing and whether this function is strictly decreasing. That means f dash x is greater than 0 or f dash x is less than 0. So we take a point x equal to 1 from the interval minus infinity to 2. That means x equal to 1 belongs to the open interval minus infinity to 2. So at this point we check whether this function f dash x is greater than 0 or less than 0. We have f dash x equal to twice x minus 4. So at x equal to 1 we have f dash 1 equal to 2 into 1 minus 4, that means minus 2. That means it is less than 0, therefore the function fx is strictly decreasing at the interval minus infinity to 2. Okay, so now you see on the interval 2 to infinity we take a point x equal to 3. Since x equal to 3 belongs to the interval 2 to infinity. So now we check whether the derivatives of the given function fx equal to x square minus 4x plus 6 is greater than 0 or less than 0 at the point x equal to 3. We have f dash x equal to twice x minus 4. So at x equal to 3, f dash 3 equal to 2 into 3 minus 4. That means 6 minus 4, which is equal to 2, which is greater than 0. Therefore the function fx is strictly increasing at the interval 2 to infinity. So from here we can conclude that at the subinterval minus infinity to 2 we have the function is strictly decreasing, and at the interval 2 to infinity the function is strictly increasing.